So, good morning to you again, sir. We would like to present the Apache Mahout framework to you today. I am Ashwari Sharma,
I'm Anubhav Chatterjee.
and now we would like to begin. Next slide. Slide. And also we would really like to express our gratitude to you for this opportunity to explore by ourselves and then learn to present the content and learn to pick for ourselves how uh, things should come together as a sensible whole. So
Thank
that's
you.
the choice of our topic. So,
And moreover, we are getting marks for this, so
yeah, I mean, we anyway wanted to really do this, but then we also get grades for this, so that's me.
that's really good.
Awesome.
Okay.
So, so we'll start with the background, bits to big bytes, because Apache Mahout is a framework which falls into the story of computation itself, and we'll see how. So, the computation begins with our standalone computing devices, and by computing devices are referred to anything that uh, does some sort of calculation that is not human, basically mechanical and physical. So we had Abacus, and then we had physical and mechanical Babbage engines and all. But then we moved on to computers like ENIAC, and two better ones like personal computers with microchips and semiconductors. But one underlying characteristic of all these things is that there is no communication between these standalone devices. I mean, the networks were not that good yet. So humans were the ones who were carrying the information if it needed to be carried. But then we got better telecommunication networks, digital networks, and that gave us an opportunity to create distributed systems, which were connections of networks, connections of computers over a network. So just like within a computer, we would have communication between different parts of the computer. We had now the capacity for computers to communicate amongst themselves, even over very long distances. So with networks and these hardware capacities came uh, and the memory, the capacity to store large amounts of data, we got the term big data, which is basically, as we saw throughout the course, which has two extremely important parts, which are storage and processing challenges, both in hardware and in software. The hardware component, it seems for now, is satisfactory, but on the software side, the open source software solutions have extremely satisfactorily taken care of the storage and data migration and system level requirements, but the processing part left a little bit to be desired. So uh, Anubhav will now take over and explore that part.
So we come to the
Anubhav, can you make it full screen so we
of course.
use the real estate a little better?
Yeah.
Control.
It's
Yeah,
not going
view.
into
Go to the view menu. Yeah.
sorry.
Control L. Yeah, awesome.
So as Ashwari talked about how distributed systems came into play, all the like we could develop systems or clusters that could be linked together, and there would be like we have studied in the HDFS system that there's one name node, and then we have the server nodes where the name node controls all the computations and all the computing things of the server nodes and everything like that. So once we reached there, there was an urgent need for machine learning. So let's look at machine learning in that way. Machine learning is nothing but where we help a machine, or rather, we program a machine to learn by itself, or and develop better and better predictive models. For the lack of a better term, right now I will be using predictive models. So now, machine learning, the more data you provide to a machine, the better it learns. That's how humans learn, that's how machines also learn. The more data you provide. And as soon as we reached distributed systems where data was stored among clusters of machines, a need was generated where the machine needed to learn from the data throughout the cluster, and we lacked that kind of a scalability for machine learning uh, programs that we use. Like, we have been using Python, we use R for machine learning techniques, but they lack that scalability to go through to each of to derive data from each of the clusters and then perform all those computations on those. So there was a
Yeah, so in fact, the way I see it, I agree with you. Initially, it was just the hard labor, so a lot of
Yeah,
processing power, a
yes,
lot of storage. So you give me tons of work to do, I'll just
yeah,
do blindless labor. So,
yeah,
but from that phase, now we are going to a phase where we are able to do intelligent things.
yeah. More
It's not
sophisticated.
just, yeah, it's not just labor. Okay, it's like I'll
Yeah,
beat you in chess. I'll
yeah,
will beat you in artificial intelligence stuff and so on. So now that we are trying to build machines which can beat human beings,
yeah,
so we are trying to leverage that ability to put that labor in
yeah,
the form of processing and storage to do something extraordinarily intelligence, which is even beyond the ability of human beings. And
yeah,
learning forms a huge component there. And as you rightly put, that's where the world is moving towards. Yeah.
yeah. We agree. Like, we really agree.
exactly. So now, as sir exactly you said that we needed more and more computational and storage powers. The first thing that comes to mind are supercomputers, but then again, supercomputers are limited. They are limited in the form that we have not actually developed something that could work on huge scale basis. So I can say that we can uh, cluster a group of like 1 million computers, and the computational power that I might get from those, if I can process, if I can harness that power, actually that computation power would be much more than a single supercomputer. And to achieve something of this sort, we needed a platform. And in this open source world where like we can generate programs where people can come in together and work around and work for generating such a platform, and then the late and for that the answer we had was Mahout.
Excellent.
So, so as Anubhav pointed, like even if we have the availability of supercomputers, the cost factors really play in a big role too, because clusters use oftentimes systems that you already have available. Resources are there with you. We are just like smartening the use of it. So if we can get some terrific output with the hardware that we already have, it's all the way better because we don't need to buy a supercomputer, even if we had it available to us. So now that we have the framework, and now that we have the basic, uh,
Background.
yeah, background to handle data operations and all the task handling, our most natural question was, can we leverage parts of this framework to develop some sophisticated automated system that would do some processing for us? So part of it was answered by Spark itself. So Spark had one of the biggest features is the iterable algorithms because of its RDD paradigm. So building all along those lines, Apache Mahout came out, and it, of course, like everything, it's building on what people had done themselves before. So Apache Mahout is a framework for creating scalable, performant machine learning applications. This is directly from their website. I'll break this down into like what they are trying to say. So they stress on the word framework because uh, it can double as a library, but it's more of a plug and play thing. Frameworks are a bit more rigid in their use than say a programming language which is Turing complete or something. But so that is one thing. But the benefit of this thing is that if a framework is already designed to do something and nothing works better, like it's out of the box, it's good for you. Now, uh, so the next thing is the Apache Software Foundation itself. So, I mean, it is a significant deal for some project to be backed by such a foundation because first, it's open source, so you have the source code, and it gives programmers some freedom to like port the code to some other places that they might need it, and it's just better for development. The second thing is free for users, so I mean, the users will like it, especially the students. And the third thing is you have a very active developers community, and
Right. Here, I just wanted to also add one more
Yeah,
thought on the word framework. It's good you took it up for discussion. So there are these three levels, if you look at it the way we build software. So at the
yeah,
lowest level is, let's say, one API or one remote method, which you can
yeah,
call and get some small thing done. Let's say
yeah,
add of two numbers, right? So you can get two numbers added together and one integer comes as output. So that's probably one small module that we could code.
yeah,
Now, when we put lots of such functions together, we have a library.
mm,
So we could have a math library, Apache Math or Commons library, and so on. So
mm,
which has a collection of related things together.
mhm,
And now we are talking about something which is even bigger. So now we are talking about a framework which puts or which brings together related things, and
mm,
each of them could be a library by itself. So
yeah,
multiple libraries which are related. In this case, we are talking about learning related, knowledge related stuff to
yeah,
come together, and big data related, knowledge related stuff to come together, and so on. So that's one way to look at framework. And
uh,
another way to look at framework is at a function level or a library level, you have the
mm,
tool, you just use it to get something done. Okay, that's simple enough. But at a
yeah,
framework level, people are even infusing some different kind of thinking on you. So they are saying, look, you have this kind of problem. Maybe there is a different way of thinking, a different approach to solve that problem. And here is a set of approaches. Like, for
yeah,
example, we
yeah,
say MapReduce as a framework and not a library,
yeah,
because
yeah,
there we have a different kind of thinking, as we discussed in the
mm,
MapReduce patterns, right? So usually frameworks bring together a collection of patterns or a collection of a
yeah,
different thinking paradigm, and it puts in front of us. So that's another characteristic of a framework. So usually people, I mean, it's very rare to listen, to this phrase that I am an expert of this library. I mean, nobody says that. I mean, it's just,
yeah,
so there is a library, you just take a library and you use it. I mean, you
yeah,
just know or you don't know how to use a library. And I don't think you need a specific practice or anything or training to use a library. But then when it
yeah,
comes to frameworks, you definitely need some kind of training, some kind of practice, because that's at a different level of complexity, and it has some kind of learning curve associated with it. I think these are some interesting things about frameworks, and Mahout interest is a very interesting framework. And as I rightly put it, it's for creating scalable, performant ML applications. What are these things? Hopefully, we'll discuss as we go.
yeah, definitely. So, as you pointed out, the framework part. So, one is in the code creation hierarchy. The second is in the functional use, and the third is the learning curve. So, I mean, maybe after the presentation, we'll upload the document that we prepared about the things that we were going to speak about. So, we'll add this part to it.
Excellent.
So,
So the
yeah,
initial release was on, as it's written, this was the initial release. It was on 7th April 2009, and then these were the initial versions that we had. So Ashwari,
yeah. So, the
Yeah,
initial,
interesting thing to note here is, even though it is 6 March 2019, we are at 0.14 version. That's the beauty of
yeah,
these frameworks. So
yeah,
the conventions are that if you have a version 1.0, it
yeah.
means the product is stable. Okay,
Ah,
so
yeah,
if you have
okay,
anything below 1, okay, it
yeah,
is 0.1, 0.01. So these things mean that they are still being
developed.
experimented, they
Yeah,
are being tried out. New things are coming up. The next release might be totally different to what the previous release was. No backward guarantees. So all these kind of ugly things come into picture. Okay, so what it means is, we are at a nascent stage. Things are at its early stages. So
yeah,
people often ask me, so Venkatesh, what do you think about the future of IT? And my answer is, people, we are just taking birth. We have not
yeah,
even seen our first birthday.
yeah,
Okay, when we reach version 20, just imagine where we would be. And those days are coming. It doesn't
yeah,
matter whether there is corona, COVID. It doesn't matter whether there's a war or a trade problem or whatever, right? These things are going to go on a different track at its own speed, and those good days are coming. So IT has an
yeah.
excellent and bright future. We are only at version 0.14. People note this. Yeah.
And it's extremely powerful. I mean, for a
Yeah.
0.14 version, it does
Yeah.
like some commendable things.
Exactly.
even at this stage.
Yeah.
So, so as we were talking about versions, so the initial version which was released in 2009 was developed from Apache Lucine's. So Apache Lucene is the search part of the Apache Foundation. So it's more about so the team ported it. So they also needed to do some linear algebraic parts for the searching of large databases. So what they did was like since linear algebra is a crucial component in actual execution and computation of machine learning algorithms, they were like, oh, why not? Let's like begin with a machine learning direction too. So, but since, as you pointed out, it's in a very nascent stage, it has gone through some significant changes between the initial versions. For example, the initial version was only dependent on Hadoop, and the current version is uh, it has like multiple backend support. So we are going to focus on the latest version, which is released, which is 0.14, and so we will talk about it and its uses and its components because over the past versions some significant changes happened, and going into details of all of them would not be that fruitful for even the user. So now as to version 0.0.14, its stable release was, as it says, on 6 March 2019. So I mean, in terms of softwares, it's very like young, as you point. Like it's small, it's young in age, but now some one of the most important things is like this framework is itself written in Java and Scala, and our coding also occurs in those languages or some DSL of Scala. So DSL is the domain specific language part, just to make our life easier. Uh, I'll just like to point out the features and then we'll go into the depths of them. First one is it's a distributed linear algebra framework. As we pointed out from its birth itself, that was the like core idea, like linear algebra. If we do it distributedly, we can do a lot of computation nicely. And the second part is mathematically expressive Scala DSL. The third part is support for multiple distributed backends, and the fourth part is about optimizations like engine bindings and native solvers. We'll explore what these are because it's not like readily apparent what they do, why they are there, like how they're implemented. So next slide. This is some. This is just an exhibition code. There's no need to go into depth of it, but it just shows like to implement some uh, algorithm like a recommender algorithm, a traditional recommender algorithm, which is like a frequent item set algorithm. Uh, the code required for pre-processing is based on Spark here, and it's maybe I mean like 10 lines, and the code required. I mean the code that we use for calling on Mahout itself is maybe not more than like 10, 6, 7 lines. So it just shows like if some algorithm is already present out of the, it's extremely easy to use. Like it's not a big deal, and like that's just we really want to point it out because it's the the simplicity of use is betraying the efficiency with which it works. Like it's extremely good, but
Yeah.
it's simple.
I remember my childhood days when we used to see this street magic, people who do some
Yeah.
magic with the cards, and we were like, wow, how are they able to do this? One day I'll become a
I'll
magician.
exactly show you, sir, how the magic is being done. I'll
Magic.
exactly show you.
Yeah. So this is nothing different, It's like
It's magic. It's magic.
yeah,
Magic.
it's a lot of things are happening, but then somehow magically you just write 10 lines of code and hardly takes half an hour, and then you have a features like feature something like face detection, so people like
Yeah,
so
exactly.
you just say I have done a face detection app for my phone,
Yeah.
and people wonder how did you do it, how much time did you, oh, it took just half an hour. Right.
Yeah, I mean, we
That's
completely.
the
I mean, it adds to the like magnificence factor of the thing.
yeah. So that's it. So we computer science guys are magicians.
Yeah. So, onto the specific features, we really want to highlight the components of these specific features because I mean they are extremely crucial to how it works itself. We'll get to the algorithms that it implements, but so the distributed linear algebra framework part. So, Apache Mahout not only presents allows you to do, implement out of the box machine learning algorithms, but it presents an entire distributed linear algebra framework. This is the like core heavy lifter of the computational part, because all the machine learning algorithms, all the search algorithms, all of these algorithms, all their computations are done in some or the other numerical linear algebra domain. So it made a lot of sense for them to create a framework for this and then themselves use it to create those algorithms. But they have also made it available to us to use to create our own algorithm. So it's not like we cannot create our own algorithms or a different algorithm besides the.
Yeah, I mean, I don't know, nice coincidence, right? So on one side you are studying linear algebra
Yeah.
of this kind, and
Coincidence.
on the other side you are looking at algorithms which are ready-made and delivered to you. Like, take it, enjoy. Isn't that beautiful?
I'll just deviate from here just one moment. So basically, we are currently doing a project on linear algebra. My group is doing a project on linear algebra, which deals with eigen voices. So it
Okay.
is like creating a model voice for all the voices that are available, and it reduces the dimension of the matrix hugely. So instead of
Okay.
using thousand dimension matrices, we can just work with 10. So that's
Mm.
how useful it is. And I found out day before yesterday that Mahout can directly implement that using hidden Markov model.
Oh, wonderful.
Yeah,
So that's two in one for you, no? So
That's two in
so
one
you
for me.
learned
Yes.
Mahout on one side, and on the other side it serves linear algebra. Awesome. Very nice.
So,
Okay. Yeah.
so now within this framework, there are a couple of key points. One of them is the data type itself. So if we want to work on something as a distributed in a distributed framework, we want some data type which is itself distributed if it cannot be put in one single machine. So Mahout introduces its own data type called DRM. It's the full form is distributed row matrices. Now this DRM, since the backends are flexible, you can choose whichever backend you want. You do not have to handle yourselves the allocation of resources or any of it, the computation parts. The Mahout will automatically do with it. We'll see how, because the language that we are going to be using is a DSL, and DSL will be converted into the low-level functionings of the backend by Mahout. So it's one of the very important things. The next thing is you have a choice to run something in core, which is basically on a system, or in a distributed form. And it's important because we can have like significant optimizations based on this. Now, the third thing is we have some algorithms which are uh, running in core is for linear algebra operations. So all the standard linear algebra operations are available out of the box, and they are available both in core and distributed form. So like you have a lot of flexibility to create your own algorithm.
Yes, and if you notice, there's one more subtle thing over here.
Yeah.
It seems like the distributed computing community love vectors and matrices. You will see a lot of them around, and many of the algorithms are based on these kind of data types, vectors and matrices. The reason I believe is that these are very easy to scale and parallelize. So you could right, so you could distribute
I've been wondering, to be honest.
Yeah, so if you have a large matrix and you want to do some processing on it, it's probably easier. And we have now the knowledge and algorithms to send it to multiple cores parallelly and get some things done.
It makes sense.
Or to multiple computers. So the one other such aspect that you will see again and again in the big data course is the idea of keys and values. So we so JSONs and whatnot, right? So everything is keys and values. Even the arrays in a way is like a collection of keys and values. So now we have vectors, which is a natural extension, and the extension of vectors is what we have as matrices. Yeah. So I think that's how we have been developing data types to deal with distributed computing. Just a side note.
Parallelizable, it makes sense. Yeah. So besides the parallelizable operations and data types, we have some inbuilt content available, which is like these are out of the box algorithms again, which are for, as it points out, distributed QR decomposition, distributed stochastic principal component analysis, and distributed stochastic SVD. So as Anubhav pointed, the voice project office would probably be using the principal component analysis.
Yeah, it does. It does. Yes.
Yeah. So now, as we already discussed, machine learning algorithms core computations are linear algebraic in nature. So it made a lot of sense to develop this framework. No, next slide. So this all happens under the hood. I mean, we don't have to worry about it. So as a user of this framework, the best feature that is available for us is this mathematically expresses Scala DSL. It's called Samsara. I think it's from the Hindi word sansar. And the reason for this is because uh, this gives us a language of uh, like interacting with Mahout, which is not dependent on the backend that it works in. So, like that is one thing. The next great thing is that usually when we are working with languages and we want to code some mathematical part, the mathematics of it is lost somewhere in the function call or the type of data type or some trans. So all of this is implicitly handled. The user doesn't have to worry about it. The only thing that they need to keep in mind is are the logical connectives between the calculations and whatever that is that they're coding. So this is one thing. The next thing is so if someone is developing an application, say in Spark, and if they want to run a Mahout code, then this Samsara will run inline with the Java or Scala application. We don't have to uh, call a specific some library within Spark itself or something. It will simply run in line with it. And as we discussed, the right ones run everywhere concept is for backend agnosticism. Uh, one more thing, this since we discussed this, Mahout is written and used in Java and Scala. There's Samsara is a Scala DSL. So Scala is itself an object-oriented language, quite similar to Java, but a few under the hood optimizations in tow. I mean, yeah. One example code is that say a person wanted to multiply two matrices and add something to it. So as we see in red, the code in red in the example is, I mean, it's kind of lost on the doer, like what is happening, what is what, and I mean, it's difficult to change it, and I mean, too many complications. The next line we have Samsara, and we have, I mean, we can see that matrices are being multiplied. The double percentage is for multiplication of matrices, and then a vector is subtracted, and so on. Like it's quite simple, and it's easy to manipulate, and it's a lot less hectic. And so next. So one of so again another thing which happens under the hood. So this was over the hood. Like this is something the programmer worries about while they are doing it. Something that happens under the hood, which is again extremely. I mean, two things which happen under the hood which are extremely significant are which backend this framework is working on. Because as we discussed, we are building upon some sort of distributed operating system, some sort of manager. So the newer versions of Mahout have become backend agnostic. It wasn't only this. Earlier, it was only dependent on Hadoop and MapReduce, but people believe that, and they turned out to be right, that different backends provide ease of computation for different types of algorithms, because those backends have some sort of inbuilt paradigm which enables different types of algorithms to be run more efficiently on them. So, I mean, technically anything could be run, but it's just not that efficient then. So
right, and it also helps us as students to kind of play around with it in a single machine. We don't need a Hadoop setup to play with Mahout. That's the best part.
Yeah, and and if as a student we want to play around, Hadoop, as in Mahout also supports this standalone capability. So if someone wants to prototype or explore the libraries available,
right. Yeah.
And the last optimization which happens under the hood but is extremely significant is in engine bindings and native solving optimization. I mean, these are heavy terms, but I mean quite simple in their working. What they have two components. One is, let's say if we call some simple algebraic operation like multiplication of two matrices. So we will be doing it in Samsara. The thing is, instead of directly converting it to the underlying engine or the distributed backend literal code, it will also look for possible optimizations if there is available. So some sort of equivalent mathematical formula which is smaller or some sort of paradigm simplification itself, whatever. So it is all happened. It is all handled by Mahout itself. We don't need to worry about it, but it's good to know that it exists. And the next thing is DRM to BLAS. So DRM is nothing but that data type we talked about, the distributed row matrix, and BLAS is the basic linear algebra solvers. So while
if for at least the math lovers or the people with math background, you must try playing around with J+. There's something called J+, Java+. It has all algebra libraries. Within minutes you can implement complicated algebraic algorithms. But that's in the non-big data world. Now we are taking it to the big data world.
Yeah, exactly. So as JBLAS is in the non-big data world, as Sir pointed, that so basically these libraries contain functions for execution of different algebraic operations. So BLAS itself is the big data equivalent of it, and these basic linear algebra operations are simply just called native solving optimization in the Mahout world. I mean, they are the same thing. It's just a difference in terminology.
Right. So in essence, 2 key points. The first point is never ever say Mahout is built only for running on MapReduce. If you do that, I'll kill you. That's a very good message. Very good message. And then think of optimizations and think of Mahout. There is something there. Huh?
We reap a lot of benefits for the hard work that a lot of other people, good-willed people have put in. It's good to appreciate that.
Yeah, I want to see you people someday become part of Mahout development community where you start contributing to their algorithms rather than. It requires people of both skills. You should have math skills on one hand. On the other hand, you should understand cloud computing, how it works. The distributed computing fund does. So you could take this to there. And that kind of marriage between maths and computer science is what we are not finding these days, a rare quality, and that's where that's where you people are positioned, uniquely in this world. At least in India, I believe this is one of those premier programs where we have the best of the minds from mathematics, learning distributed computing and algorithms, and then I think that should be your USP in your resumes.
Yes.
And these are the kind of jobs that you should target, which are extremely highly, reputed. Skilled. Yeah.
Oh. It's a great thing because this development of projects itself is a lot of joy besides just using them. And if there's a skill that we can contribute to, we would be very happy.
I'm sure these guys are always looking for people who bring these two kind of skills together. We do get. There are tons of diploma programs outside which teach big data, machine learning, but they don't teach mathematics. There are tons of mathematics courses outside. They don't teach distributed computing. Show me a course where they teach both of these really seriously in a very formal way, with the best people in business. So that's where I think we stand apart.
Yes.
It's a unique.
That's where we have the edge, actually.
That's what?
That's where we have the edge over
other courses. Exactly. Yeah.
Moving on. So
now
So thank you, Ashwari. So Ashwari explained in very nice detail, gave a very nice detailed explanation about how the backend features are working for Mahout. So I'll just start with a bit of trivia. So Mahout is derived from the Hindi word Mahavat. So for people who do not know Hindi, it's from Mahavat, and it means the rider of an elephant. So
that's a surprising Indian influence, isn't it? We just now heard Samsara, now we are saying Mahavat, and what's going on here? We are talking about machine learning, distributed computing, Apache product, and here we are talking about all Hindi Sanskrit words.
We Indians have always had a nice influence over the world.
Yeah.
At least the computing and the math world.
Maths world, definitely.
Yeah.
So basically, we can see Mahout as the rider who rides the Hadoop environment to produce scalable machine learning capabilities. So, so that is why, since Hadoop's mascot is an elephant, and it made more sense to name it as Mahout. So it's a very apt name, I would say. So moving on. Okay, so from now on, I would be using a lot of references to Mahout as the elephant. So let's look at what the Mastodon can do. So the basic machine learning algorithms that we learn, or any data scientist or any ML specialist would know, are the three topics that are supervised learning, unsupervised learning, and recommendation system. I would just go over them in a very quick jiffy. So supervised learning is where you know the data, where it's labeled data, and the computer, it's like a teacher teaching in a class. So you learn something from the teacher, and then you improve yourself. So the machine learns itself from the data, that is the labeled data that is present given to it, and from there it learns. So there are two types of supervised learning. One is classification and one is regression. So classification is used to uh, segregate data points based on certain features, certain similar characteristics, whereas regression is used to let's say predict a certain trend. So for example, the current coronavirus cases, so I can give an example of a classification and a regression. So given the symptoms of a patient, classification would be if he has coronavirus, or if he has the COVID-19 virus or not. Regression would be how many coronavirus cases would be arising in the next few days. So these would be the examples for classification and regression. In unsupervised learning, we have mostly we have clustering, where the data is not labeled. We are just given random uh, unstructured data, unlabeled data, and we just tell the machine, do what you want with this data and give me something meaningful out of this. And the machine clusters the data and says that I have found these data points that are similar in certain aspects, these data points that are similar in certain aspects, and the other clusters like that. So you could give a machine a picture of dogs and cats and not tell them it's dogs and cats, just some animals are there. You give it to the machine and ask it to group it. It finds similar patterns, like dogs, like cats have smaller tails, pointy ears, whiskers, and like that. And so it segregates the cats, segregates the dogs. It doesn't know that these are cats or these are dogs. It just knows that these are different kind of things and these are different kind of things. Next comes recommendation systems. So recommendation systems are the one of the most seen of systems that we come across on the internet or on the computing world. So as soon as you open Amazon, you are shown a recommended list of items that you might want to buy. Or and amazingly, it's how amazing that has this ever happened to you, that you dreamt about something and the next day you had the recommendation for that particular item on your Amazon. So that's how, like,
Yeah, not just Amazon, it's everywhere, right? So you
it's
open
everywhere.
Facebook and
Exactly.
somebody's selling the same thing there. I don't know how they read my dreams. Even if I just dream and then wake up and it's there everywhere.
It's there everywhere. It's
Just kidding.
amazing.
Yeah, that's true. That's true. That's true.
So
And,
so these
is there
recommendation
also,
systems,
yeah,
yeah.
it's also interesting that, so probably at this stage, even in our dreams, we could solve a regression problem or a classification problem, with a pen and paper. So let's say someone says, okay, draw the regression line or something like that. So these are not difficult for us. We understand the math behind it. So we know how to solve it. But the point is, when we try to take it to scale, and when we have a web scale items, like millions of items or petabytes of items there, and then we have to apply all these things, suddenly the same problems become extraordinarily complicated. Now we have to worry about how to do this in sub-second response time, how to do it so that I don't I don't overflow from the memory perspective on my machine. So how to put the infrastructure of my commodity hardware to work. So lots of distributed computing questions comes into picture, and we suddenly become novices, right? So now we don't know how to do things, even for such basic stuff. And these kind of libraries come to the rescue there. So now I have the tools and the technologies and the frameworks to implement the same ideas at that scale.
And thus we have the scalable machine learning algorithms and machine learning techniques that Mahout can perform on distributed systems.
That
So,
explains the scalability, but yes, exactly.
so
Yes.
now what the elephant offers to us. So the out-of-the-box algorithms that that Mahout framework offers to us are these are some of the very famous algorithms in the machine learning world, and I would just go over them quickly. So collaborative filtering is suppose that we have a big set of people and they have certain preferences, and from there I want to judge a particular person's priorities. So I get a smaller from that bigger set, I'll get a smaller set of people who have the similar kind of preferences as that person, and how that smaller set would react to a particular recommendation. So based on that we would recommend something to that other person, for that particular person whom we are doing the filtering for. So these
Right.
are how recommendation systems are based on. Next we have
10 of
classification.
you from CMI are buying Baga's book. So obviously, if you are coming to Amazon and looking for a book on big data, hopefully you're also looking for Baga's book. Yeah.
Exactly.
Yeah.
So next we have classification. So classification is usually when you want to classify, like I said, we have a classification model. Let's say the COVID-19 or a cancer or tumor is cancerous or not, or it's malignant or not. These kind of classification problems. Dimensionality reduction comes in cases where I was talking about the eigen voices data. So when we are looking at when we want to reduce, so we many times we notice that after a certain point of time, we everything is basically based on matrices. So we notice that after a certain point of time, the matrix values are so less that they hardly contribute to the rank of the matrix, and we can understand that even if I remove those entries of the matrix, I can reduce the rank of the matrix and work with a lower matrix that is similar to the higher dimension matrix. So these kind of processes are helped in dimensionality reduction techniques.
Exactly. Yeah. 3 by 100 gives the same information as 100 by 100. So why bother working with 100 by 100? So
So
three
very
features
well.
are enough. So these are my prime features. Awesome.
Yeah.
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 Then we have clustering. Like I said, we have unsupervised data. We just give it to the computer and say, cluster it for me, and it clusters it for you. Like I gave an example of cats and dogs and everything. So we usually we can look at document clustering, which is one of the major things that happen on the Google. What Google does is document cluster. So when you give it a search query, it automatically groups a certain kind of documents. So you should try this with the scholarly articles. Like you
Yeah.
give them some scholar articles, and it gives you a bunch of documents that are related to that particular articles. So that is how document clustering is done by Google. So
Right. Nowadays,
then
almost everyone knows the difference between classification and clustering. But just for records, if you know the classes and then you are trying to put the data points into the class, you are doing classification. If you are not aware of the classes, you are trying to bunch the data points together, and then you are doing clustering.
Clustering.
Right?
clustering.
Yeah.
Then we have some miscellaneous problems that we have, like frequent pattern matching. So this is like frequent item set mining would be the biggest example of this. Like when you go into the when I'm a supermarket owner, I want whenever a person buys bread, I want and I have seen that a person buys bread and eggs together. So I'll keep the bread and eggs together in the nearby section. So even if a person might not need eggs, he buys the bread and he automatically says, okay, I might need eggs, and he gets it. So this is how
Uh,
frequent item set mining helps.
I just hope the Avenue supermarket guys are looking at this talk. Uh, they know where to find the next generation employees for operating their business, to improve their recommendations. Yeah, so here are the two. All right.
So these are the some of out of the box algorithms that
One thing to notice here is that like we have a large, a very dense product structure, so to speak, the out-of-box algorithms. But the core working component is still based on the linear algebra library, which only had 3 strategic components. So from 3 we get so many things, and it's just like the scalability of a major
everything
set.
boils down to final matrix computations. Like
Yeah.
all of these
That's
algorithms boil down to
exactly.
matrix.
That was just running in my mind. So look at the fundamental data types. They are so simple, and
Yeah.
they
Yes,
just, it just matters us.
it just
Yeah.
matrix. Everything boils down to that.
Yeah,
So
vectors
that is
and
why the kid is so scared. Like, are you?
yeah.
Okay. So what are the big shots that are riding this elephant? So we look at Adobe. Adobe, we have Facebook, we have LinkedIn, Foursquare, Twitter, Yahoo. Everybody is using Mahout for various kind of things. So I would
Yeah.
specifically like to like these things are very pretty obvious. Like Foursquare is using it to recommend food options for you, restaurants for you, what movies to watch, what magazines to read, and everything. Twitter uses for interest modeling. It's a basic form of clustering technique where it puts you in like what kind of interests are currently going on around your place. It shows you those kind of tweets and what might interest you. Yahoo uses it for pattern mining, so pattern among people searches, people what websites they are visiting and everything. The specific that I wanted to talk about was 365 Media. So 365 Media uses an amazing collaborative and mix of collaborating and classification to get the news, it actually it actually takes into the data set all the news that is business news that is generated, and from there it automatically gets the information like which CEO is doing what company is dealing with what shares are going down, what shares are going high, because of what reasons. So this is uptime is one of the like very interesting uh, mo- build that 360 media has come up with, and it is really amazing. Like people should seriously go and look into this, like how from
Yeah,
huge
true.
business news they have come up across, like they judge like market prices based on what company internal company things are happening, and that data they get from just the business news that are going on in the market.
Oh yes. So at a high level, I believe it's media and social media on one end, the e-commerce guys on the other end. So
Mhm.
these people heavily use
Mhm.
these
Yes,
ideas,
yes, yes,
recommendation
Yeah.
systems.
yes. Okay,
I mean, wherever
so
we have a lot of like information accumulated in a domain, like digital information, they
Oh
would
yeah,
like trying to.
yeah.
I think
Just
government should also do it for the benefit of the people, but then it's a slippery slope. So wouldn't recommend it too much.
yeah. Let's not go there.
Yeah.
okay, let's not go.
Yeah.
Okay. So now we have seen what Mahout can do, and now I'll show you the where the magic happens. So, okay. So getting started, how to tame this beast. So I will demonstrate two such cases where I would take in considering one clustering technique and one recommendation technique, and I'll explain how things are working. So this basic demonstration works on the premise that Hadoop environment is up and running on your system. Okay. If not, Google it, and if not, ask Sir. Sir will help you.
Oh no. Okay.
Lots of
Dude,
hope, Professor.
it's too damn high. Like the meme says, it's the number of steps are too damn high for installing
Yeah.
Hadoop.
And
I mean,
that's
if you have
why
a
that's why
package
we need
manager,
people
then it's
like
not a
you.
problem. So that's why we need like something like APD get or something like managing
Ah,
packages and dependencies.
a
I don't want
tad
to
bit
do it.
deviation. A tad bit deviation. Can I ask why doesn't Hadoop develop a user interface?
I mean, it
Uh,
has Maven, right?
Well, that's what
Government
Cloudera is
managed.
doing, right, for you. So
Yeah,
Hadoop didn't do it. Hadoop guys focused on the core engines,
yeah,
but the Cloudera guys saw the opportunity and they jumped on it.
yeah, yeah.
And in fact, Cloudera has a bunch of Hadoop guys in them. So they did exactly the same thing. And then Amazon came in. So now we have Amazon series of managed stuff. So everything is just click of a button on web. So just log in, create an account, buy 10 computers, buy a cluster which is running either Hadoop or Amazon's technologies, install
Mhm.
whatever you want, and get going. So yeah, it's that easy. But even Microsoft does it. They have been doing it for a long time. So they have this Azure platform,
Yeah, yeah.
so which has
Yes,
excellent
sure,
UI.
sure. Yeah,
You
yeah.
think of UI, think of Microsoft. Yeah.
And then the Spark, the co-founders of Spark also started this company called Databricks. Same concept.
Yeah.
Yes. Okay. So the first thing that we need to do is we need to install Mahout, and for that we go to the particular linked website, and you can extract it with the following command that I've mentioned in this. So now this is where the magic happens. Okay.
Hmm.
So this is a recommendation system that we are building to predict movies based on how much they have rated other movies. So the dataset we're using is the group lens movie dataset. It is linked up in the presentation. You can download the exact dataset from the present link. What See, this is the magic. Like, this is so amazing. So you uncompress the archive, you download it, you uncompress the archive of the data, you copy the data into the HDFS, and you run the command. That's it.
Done.
Yeah,
Done. That's it. Done. And abracadabra, we are done with it. You run this particular command. So I'll just go over the command once. So basically, Hadoop jar, it's Mahout directory where Mahout is. It calls Mahout, and from there it calls the particular algorithm that we're using. That is the recommender job, and it is similarity concurrence is the what kind of similarity we are using for this particular current. I don't think I've mentioned it here, but I'll go over it. For this particular technique, the similarity concurrence is we are basing on if two or three people have named have similar kind of ratings for the same movie, we consider that to be of the most appropriate rating for that movie, and based on that we recommend the movie to the person we are looking for. And so now once we run the command, we automatically generate an output file. So to merge the total output file for all the 10 people, so we merge it, get merge output.txt, and this is the output file how we are generated. Yes.
So this implementation is using Java and non-Samsara based Mahout framework. So this was a use case since this use case was tried and tested, and hence the commands presented are in Java. But even then, it's quite small. But it only gets tougher when you're trying to implement your own algorithm or something. It's very crucial to use Samsara, because then you'll have to write huge Java code files, etc.
Correct. 80% of the needs are pretty similar to each other, so it's just usually easy to take one and just adapt it a little bit and get another one. But yes, so there are still so we encounter new stuff, and so contact us if you want something new to be done. All right.
Now we'll move on, and Anubhav will move on to the future developments, and then we'll conclude.
Okay, so I'll just go over the clustering ones quickly. So the clustering ones is, again, I'll show you the magic over here. You basically, for the clustering algorithm, we need to make three directories. So one would be the actual data, one would be the output cluster data where we are going to put it, and one would be the Mahout sequence. So the sequence is like the cluster parameters that you need to take for clustering the data. So over here I have done it with a random data, mydata.txt. It's any random text file. So this is something important that I want to highlight. So we first need to convert the data into a sequence file. So a sequence file is a key value pair file, and it was first initially brought up so that Hadoop does not face the issue of multiple small files. So if we have multiple small files, we can just compile them into one big file where we can keep the name or location of the file as the key and the content of the file as the value. So it negates all the issues of having multiple files in Hadoop, which is a very unfavorable way of using Hadoop.
Yeah, so when we are working with chunking as our technique, we don't want the chunks to be wasting memory with storing small files. So bunching a large number of small files together makes a lot of sense.
That is why we use,
because the block size is large.
So these are the basic commands. You just make the directories on the last command, HDFS Mahout sequence cluster data, and then you just run the command Mahout Canopy. This is a Canopy. Just run the command.
Magic.
Magic, and this is what happens.
Yes. And another extremely fun part is like the sequencing and all that we manually did right now. It is now getting automated into the Samsara framework itself. So probably in the next release, we don't have to do anything manually. We'll just give them the data type, and it will check that Hadoop is the backend, and it will automatically optimize the storage.
Wow.
I mean, it's getting too simple, to be honest.
We are getting a lot of
Like
stuff
Sir
for free.
said, we are not
Yeah,
even at the first
exactly.
birthday.
Yeah.
Sorry, what?
Like Sir said, like we are not even at the first birthday.
Yeah, it's not
Yeah.
even the first one. Exactly. Yeah. So look at,
Uh,
it's the world. The world is going towards free food now.
Yeah. I mean, I really appreciate that change. Like,
Here
all
at least,
do,
yeah.
buddy. We all do.
yeah.
So the prospective future. The future that we see, of course, Mahout has a very vibrant and bright future, we can say, because first of all, the backend is so agnostic. Sansara uses the right ones, use everywhere. You can write it here, you can write it there, use it anywhere you want to feel like, in any method you want to use it.
So,
Then,
one second.
yeah,
The thing is, with backend, wait, I'll take this one, you conclude.
sure.
So for backend support, the thing is, whatever current distributed backends we have, even if the backends change, say we have some, like besides H2O or Hadoop or Spark, we get some other backend, your code will not, I mean, the code will still be maintained. Like if you have implemented something, because of the backend agnosticism of the language, we can simply port the newer backends to this resolution. So, I mean, newer backends will be added, the code will still be there. So, this is the second point, right? Once use everywhere one. So, newer backends, old backends, whatever happens, the code doesn't need to be changed. The second thing is, uh, uh, as you pointed out, like under 0. Under 1, we have still not this very stable releases and still in some testing and development phase. So the next release, as given on the Apache's Mahout's official website, is for version 14.1. They said like the strange numbering is because of the very point you said that they wanted to signify the stability of release, and since the last one was 0.14, they wanted to point to 14.1 and then take it from there. And the
Yeah,
last
so
thing,
I must
yeah,
note that if you look at the versions of Mahout, you will see 0.1, 0.2, 0.3 going up
yeah,
till 0.9. And
yeah,
after 0.9, it goes to 0.1112 and then
yeah, yeah,
1.4 and so on. So 1.4 is not between 1.1 and 0.2.
yeah,
You know,
yeah, yeah, yeah,
so,
definitely, yeah.
so we are defying mathematics here.
It's yeah. So like it's more like a concatenation thing and the place of the decimal point. So version control, as usually we do, it will be dependent on the features or the some sort of thing that we want to group together. And if they fall into the same category, we would want to start adding decimals or iterations to the thing beyond the decimals. But since we were already beyond the decimal, so like they
Yeah.
could,
Yeah, so I just opened the Mahout download page. So if you look at it, the version numbers are like 0.1 to 0.9, and then you have
yeah,
0.10.0, and then
yeah, yeah,
0.10.1, and
yeah.
so on.
And the last thing is, as we already discussed, the Apache community. The Apache community, the software foundation itself, these things are extremely important for the health of a software itself. Like in the moment, maintenance provided in the future. So, I mean, currently it's going extremely strong. So, I mean, we are extremely hopeful towards where it's going to be taken, as you pointed out. I mean, it's just birthing right now. So, here's to whatever can happen, magic. So now Anubhav will conclude for us.
So the whole takeaway from the presentation should be that we have Mahout as a very mighty beast. Like it has the potential. Rather, it is doing wonders around the world, around the globe, over the whole distributed computing thing. We have various kind of recommendation system all over, all spread out over all kind of social media, like you said. We have Amazon, Facebook using recommendation system. We have this various clustering algorithms. Google using the clustering algorithms for document, for page ranking and all these things. So the 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 points that need to be taken are, it's easy and efficient. The whole, as we saw, it was like 4 lines of code it took to cluster a huge data set and 30 minutes of time. It took me 4 lines of code to generate a recommendation list for a person who wants to watch a movie. So these kind of efficiency is difficult to achieve over distributed systems for
Mm-hmm.
any other, at any other framework. So, and again, that point comes in that it has agnostic backend, so it can handle multiple cloud backends. And so the mathematical language, since we are using Mahout for mostly mathematics-based calculations, and so usually if we use the mathematical expressive language Samsara, we have it's easier, much easier. It is free and open source, so there's continuous development from more and more people because it is free, so more people can readily access it. And since more people can readily access it, more people want to improve it, and more the people want to improve it, more the people are getting involved in improving it. So this is why it will see a huge boom. My personal point, or rather our personal point, is a personal viewpoint is that it will see a huge boom, and it will have a very long duration of continuous support and development in the future. And so
Exactly. In this course, at least, we have been discussing big data platforms, and our focus has been on the big data, how to handle it, and so on. But if you notice now, we are at that level or that stage where we are no more worrying about how to handle big data. We are now worrying about how to build applications that leverage big data and do some magic, like what we have seen. So that's the switch, so that takes you to a very different set of courses. So now you can consider, let's say analytics is one stream to go and pursue. Building, machine learning is probably another stream to pursue. So we have another course, information retrieval, coming up. That's another thing to pursue. So these kind of things are coming up. So where to go from here is answered in this talk. So now that we know how to handle big data, so it's time to go and build some serious applications.
So with that, we would like to thank you.